In this session, we look at the relationship between two variables. The statistical relationship between two variables is referred to as their correlation. Correlation means association. More precisely, it's a measure of the extent to which two variables are related. If an increase in one variable tends to be associated with an increase in another, then this is known as a positive correlation. An example would be height and weight. Taller people tend to be heavier. On the other hand, if an increase in one variable tends to be associated with a decrease in the other, then this is known as a negative correlation. An example would be height above sea level and temperature. As you climb the mountain, there's an increase in height, and it gets colder, there is a decrease in temperature. When there's no relationship between two variables, this is known as zero correlation. For example, there's no relationship between the amount of tea you can drink and the level of intelligence. A correlation can be expressed visually using a scatter plot. A scatter plot or scatter diagram provides us with some insight into the correlation between the variables and possible models to describe the relationship. With a scatter plot, one is able to scattergram to plot the figures for one variable against the figures for the other on a graph. First, let's look at the scatter plot with a positive correlation. The points lie close to a straight line, which has a positive gradient. This shows that as one variable increases, the other will increase. Notice the straight line freely passing through the data. Its slope is positive, therefore implying a positive correlation. Next, we look at a scatter plot with a negative correlation. You'll notice the points lie close to a straight line, which has a negative gradient. This shows that as one variable increases, the other one decreases. Finally, we look at a scatter plot with no correlation. As you can see from the scatter plot, there is no correlation between the grades and time spent on an exam. You'll notice there is no pattern to the points. This shows that there's no correlation between the two different variables. Next, we look at how to graph qualitative variables. One way in which we can graphically represent this qualitative data is in the form of bar chart or pie chart. Now let's look at the bar chart. A bar chart is made of columns plotted on a graph. The columns are positioned over a label that represents a categorical variable, like the color of a ball or the breed of a dog. A bar chart is especially useful with comparing two sets of data. For example, comparing the age of boys and girls in selected leisure activities. Next, we look at the pie chart. In a pie chart, each category is represented by a slice of the pie. The area of the slice is proportional to the percentage of responses in the category. This is simply the relative frequency multiplied by 100. Each piece of a pie chart corresponds to some subset of the sample or population. In this case, we can use the contingency table rows to subset the sample. A contingency table is a type of table in a matrix format that displays the frequency distribution of the variables. A two-way contingency table is a display of counts for two categorical variables in which the rows represent one variable and the columns represent a second variable. For example, from the following contingency table, we can clearly see that females prefer cats more than dogs, and males prefer dogs more than cats. In this session, we looked at the graphical methods to show the relationship between two variables, that is, the correlation. In our next session, we'll learn how to calculate the three main measures of central tendency commonly used to summarize a set of data: the mean, the median, and the mode.